Hey, what is up, everybody? Welcome to another Wednesday Coding Minds Project web conference. The hosts for tonight are Angel, Nina, and I. Tonight's presenter is May King. May is a junior in high school, and many of you know what doodling is. But those of you that don't know, they are free-handed drawings that people sketch when they're bored. So doodling can start from a small figure to a whole page of detailed artwork. So May here has come up with an AI program that connects the idea of doodling to neural networks. So without further ado, May, whenever you're ready, you may begin.
Hello there. Okay, then I guess I'll get started. And I have a presentation ready, so let me just get that up. Okay, so before we go into the presentation, thank you for the introduction. I am actually a sophomore, but I am a sophomore at University High School at Irvine, California. And yes, I built an AI program that is capable of basically recognizing and identifying human drawings, and it's kind of able to pick out what is that you drew. It's able to classify what has been drawn by a person. And the reason I chose this project was it's interesting to me that we are able as people to look at this weird image. It might be meaningless, and it's completely meaningless to anything like a computer, and then somehow we're able to recognize this and identify it as an object. And when we take a computer to be able to do this, it needs to be able to recognize patterns that we see as people. And this is why I guess, well, I'll explain more later, but so my specific program is called Sheep, and it's an odd name, but it's mainly because the program itself is, again, it's an artificial intelligence model, and it's basically been trained on thousands of human doodles of random objects. And it's the type of artificial intelligence, it's a deep learning model, and it's a neural network, or it's a convolutional neural network. So to fully understand what's going on and how it's processing all this information, I probably should first explain that what a convolutional neural network is. So sometimes they're called CNNs, convolutional neural network. So basically, if we look at a neural network, it's basically, it takes in data and then it outputs another set of, it classifies it. So normally for convolutional neural networks, it's often used in image classification because it has this really neat ability to identify patterns, and that's super useful when you're trying to look at something in an image. So first, we start off with an input layer. So imagine you take an image, and normally to us, we look at this image and we see colors and then we see objects. Well, the computer can't really see color, so we have to put it into numerical values, and usually that's what we do with pixels. Each pixel has a color, so that would be registered as red, green, blue values in arrays, and basically it puts all of these into a format that the computer can understand. And think about this kind of black box in the middle, and we'll go into what kind of goes on in there, and then basically it goes through this black box and outputs a class or whatever object that neural network has decided that it is. In this case, it would take an image of a drawing, let's say, I don't know, a cow, and then basically, hopefully, at the end, it would say, yes, this is a cow because of everything that's happened in this box. So within that area where it's made a decision, what this neural network has done is it's kind of adjusted its weights on what to focus on. So it tries to find specific patterns, and it looks at an image and it goes through a bunch of different it puts a bunch of different filters on the image, and each filter think about as like a little screen that tries to pinpoint certain things. So one filter might try to look for edges or look for circles, and each time it outputs a different image, a different version of the image that kind of highlights, say, a certain edge. And you do a bunch of these filters, and they get more and more complex as more information and more patterns are found, and all to the point where you can identify objects. So how this would work, this is what it's called convolving. So basically, it takes a set of, you can see 3 by 3. It's a set of 3 blocks, and it's moving across an image, and it's kind of simplifying the image so that, look at this 3 by 3 block is simplified into one block of data. And that kind of, it just focuses on what this filter finds is most important. And all the filters do this, and that's where we get, so this is the same image, and it's just going through multiple filters. Each filter is finding different values because it's looking for different things. And eventually we get an output here of combined information from all the filters. So then, hopefully that's not too confusing. So then another way to put this with another example here. So I don't know who this person is, but basically this is an image, and each layer has found different things. Perhaps this one is looking for lighting over here in this image. It's a filter that's looking for the brightest spots, lightest colors, and it goes through all these different things, and different filters are looking for different parts of an image or patterns, and at the end it's able to kind of combine them into and pinpoint it to what it thinks it is. So so I want to take this back to, that was a kind of brief, quick overview of what a convolutional neural network does. So about sheep specifically, sheep has 9 layers, so meaning it kind of goes through this process of reassigning weights and values 9 times with a bunch of different filters in each layer. And so in the process of building sheep, I took a lot of inspiration from another person's project, and this person's project was called Sketcher. Maybe you can find it online. And they designed a very similar piece of code, and I kind of took their code, and I found that there were some bugs in some places, such as in the optimizer. And then an optimizer is just something that basically makes the code accurate, and I changed the optimizer. I changed the data set that the code was trained on, because it was kind of, I felt like was a better, more extensive data set. And then in order to use this, we had to do a lot of manipulating images, changing it from different data types so that it could be inputted into the model. So in the future, I'm hoping to be able to, because right now because of switching data set, it caused certain issues to occur with the moving of files and transferring, some strange things happening, and they're very simple bugs. So the program itself actually works, but the issue is feeding the program certain pieces of the data, because we haven't gotten enough data yet for it to be trained on. And also it would be really nice to be able to build an interactive front end, or just kind of like a website or a web application that would allow us to easily use sheep. So this is just a sample. I'm going to do a demo very soon. But basically, this is just implementing the code right here. This is building the convolutional model. You can see that we have the model here, and then we're just adding layers. So you see sometimes we add convolutional layers, and then sometimes pooling. Pooling is similar to a convolutional layer, but it's kind of, again, it's condensing the data so that it's easier to process for the computer. It's faster. And then, so I'm going to bring us over here. Okay, so this is my Google Colab where this is sheep. So first things here, this is just importing all the things that I want to use, libraries. And because the images are in my Google Drive, and I'm lazy, I don't want to upload a bunch of data, and this basically has it retrieve the data from a certain folder on my Google Drive using this basically like a map to where to find it. Here are the list of names. Basically, during the training process, we can think of, we're constantly testing. We're giving the model an exam. We give it an image, and then the answer is what the image is, and then basically it gets checked and it gets scored on however it got corrected, how many got correct, and kind of reevaluates. So it's opening file names, it's reading all of the names that different objects can be. So then, and then here we go. This is where it's loading in the data, and it's kind of separating the data. It's just received a bunch of data, now it's separating into where it wants training and testing, because we want the data, so a certain amount to be for training, to be making the model, and then another amount to be for testing the model, to making sure that it actually works. So here we are, and then this is again making sure that it's in the right format, and here the actual model itself. So I don't want to go too in detail here, but again, it's adding layers. Padding is basically just, if you look here, sometimes this 3x3 little thing, it goes outside, it'll go outside of, sorry, it sometimes goes outside of this one area, and this kind of leaves some room for noise and stuff, but then it compiles, and then this is a summary of how it did. So this is, we just build a model. Now here is where the issue arises. So because there wasn't enough data provided to it, because we were having issues with, we didn't have enough time to generate the amount of data that this program needs to run. This is why when it tries to fit the model to everything, it tries to make it, there's a minimal amount of data it has, and it's not enough to build an accurate model. That's what this is. Originally there would have been a plot to also show. It was a nice visual, and then printing out all the data. So there you have it, and then this was just a little side thing. Because I switched the data set, so this is just taking the images and taking them from the PNG data format to the NumPy format, and this isn't really relevant to the actual purpose of the project, but yes. And then here is where the original issue is that it's trying to it's having issues organizing the files. So here is a sample of the data set that I was using. This is from crabs. These are people's drawings of crabs that it was trained on, and basically the program would try to find things that are common among all the crabs, such as perhaps it sees that there's constantly this kind of legs, like these 3 legs sticking out, or constantly there will be these kind of C-shaped pinchers, and it'll try to identify those kind of patterns and classify anything with those patterns as crab. So I guess I'll be taking questions.
So, can you guys hear me?
Yeah.
Yeah, so let's go on to questions. And also, is it possible to like test out right now if like the audience member wants to draw a picture, like is it possible to insert it into the program right now?
If they are, well, the thing is, the issue is still there with the fact that it's the model is having difficulty trained because again, there's not enough training data that's ready. That's because this is basically prepping the data to be sent to the model. So if someone were to try to draw it, it would require resizing the image, and it has to go through this, and then the model itself isn't, I feel like it's not well enough trained on like the minimal data it has. If it had more data, then yes, I would totally say we could try it out. It might take a while, but not now.
Okay, cool. So then let's have the audience submit questions in the chat or just say them. Also, I'm not sure if you mentioned this in the beginning. Why have you decided to name your program Sheep?
So basically, it was a little bit of a random name, but when I was first looking at things that I wanted to do, I knew I wanted to do something with kind of some kind of recognition, because again, it's interesting like how our brains are able to do it, and then how we do get computers to do it. But basically, when I first stumbled upon the idea of doodling, doodle recognition, it was with it was a Google set of a bunch of sheep doodles. And I thought it was the most random thing ever, just like a bunch of sheep doodles. For example, for some reason, Google had gathered, and basically that's what kind of got started. So I decided I might as well name the program Sheep.
Cool. And how long did it take you to make this program?
I believe.
Oh, no one can see me eating it. Okay.
I believe it took. I think we spent about the last couple of weeks, I would say. I mean, obviously, it's not like I'm working every single day on the project, but probably like 8-ish hours total.
That's actually pretty fast. Oh yeah, where did you get all of your training set data?
I forgot the name. I'm bringing the name right now, but basically, it wasn't Kaggle, but I think it was a university, or basically it was data I found online, and it was some kind of I think it was a university that was doing a research project, and basically they publicly released all these doodles as PNG images.
Okay, that's very cool. Okay. Do we have any questions from the audience?
So would your program work if the image has different colors?
Well, not quite, because the issue isn't exactly with the colors. For example, here, because the image, the inputs it's given doesn't actually have any colors. It's just black and white. So it's kind of just, you can see here, it's changed the colors, but it's just looking for these two are very contrasting colors. So that's why it's this kind of color. But probably not. I mean, maybe, but the issue is just that there's just not enough data. And at some point when it was running on its original data set, it did work, and we got some nice outputs. But after changing the data set, that's when problems started to occur. So I'm not sure. I don't think changing the color, unfortunately, would solve the problem.
Okay, well, I'll ask another question since the audience seems to be quiet. So what do you think is like the future of like image recognition and like especially maybe doodle recognition? Like, what do you think the significance of that would be in the future?
Well, we can already tons of things with information, and I believe the core of this project was kind of finding patterns in images, and that's kind of again the basis of image recognition. And where I see this going, it's already been heavily implemented in like governmental things, like identifying different people, different faces. Same thing with like even so I guess doodling specifically, perhaps it would be useful in applications of. This is kind of just a fun project, but I guess it would make. So I think the doodling part was kind of a more fun part of the core idea that perhaps we can use this to model something that a person can do. We can figure out how we find these actions, how we are so easily able to identify certain things that, and then how do we get this other thing to do that? And when we look at a picture of a dog, it's completely meaningless to a computer. But then how do we generate meaning out of that? And I think it's just interesting.
Yeah, I definitely agree. It's a very good explanation. But yeah, also I think maybe even like tracking handwriting, like of different people, can be used for many things.
Yeah, for sure. It's already on a lot of applications that are able to do that, kind of recognize handwriting, and then we have things that go from writing to text, certain like translators. Yeah, it's.
So you created this program because you doodle yourself?
I do like to draw sometimes. I guess I do. I guess I could send my doodles into this program, see how good they are. Maybe it's gonna tell me it looks super bad, and then it's not. It's gonna tell me my crab looks like a chicken or something. But I think that definitely did play some part in it. I already had an interest in kind of creative aspect, and that would, yeah.
Sounds good. Also, do you think your program might lead to maybe signature recognition?
Signature recognition.
Because signatures, the scribbles are kind of similar to doodling sometimes.
True. That I just have a feeling that since this program is looking for certain, so let's just take a look at this crab dataset real quickly. So I'm not sure if it would recognize certain signatures because of the fact that what it's looking for might be a little bit too general, because signatures, unfortunately, they look very similar and they don't have as many distinguishing characteristics as this like crabs to for example, banana. So there's a lot more differences between a crab and a banana than a signature and a signature. But if it were to be trained on more detailed images of a different people's signature, it's just that this program looks at things too generally, I think, to be able to recognize signatures. But it's possible if it were trained on more detailed things, had more layers, was able to create them more complex, generate more complex answers like that. Because you can see like there's a big difference between that banana and that the crab that people can see, and sometimes people can't even recognize different people's signatures. So
Good point. So if there's more data to train, then it's possible.
It's yes, but it's not. Again, it's not only about the data. There needs to be more filters applied. Well, not only more filters, more weights. It's a little bit different. This model isn't made to something that general. It's just that its weights are different. Its weights are less specific, and it would need. You could definitely use I think you could use convolutional network, which is basically recognizing patterns. Just not this one.
Okay.
I see a question in the chat. Justin said, have you ever tried bigger and more complicated things like a building or like a vacuum or something, or like boxes of bananas? So I think bigger things. So here the things has been trained on and has a pretty good grasp on things. So I think it might actually be trained on like a building, because in the big scheme of things, it can't actually see size, but like a building would have common characteristics. Like if you were to take an apartment building, it has, you might say, the windows, you see a bunch of squares that people automatically think of. So, and I think it would be able to recognize buildings if, so right now it's even trained on this churches. So yeah, because they have enough distinguishing characteristics that are broad and common that I think it would be able to do that. The vacuum cleaner, probably as well. As you can see, it might see like, oh yes, the common cross, and it sees it, and then it thinks, okay, the distinguishing characteristic of being a church, it has a triangle, and usually leads up to this T-shape.
Is your program an existing app?
No. I would like, as I mentioned, I would like to develop some kind of front end with it, probably with like Dreamweaver, Adobe, or something like that. But I guess we have to, once it's trained, and then we put it. Yeah, well, that's definitely a future thing, not currently. If one were to want, if you did want to try to use just get a recognized, Google has a really cool one. What is it called? Not Doodle for Google. What is it? It's like a Google doodling game where they have an AI that's capable of. It's like a game. You draw something and then it tries to tell you what it is. You can probably find it online right now. It's really easy. Another question in the chat. Matt asks, is there anything you would add to improve the project? Definitely, first thing, fix those bugs. Get those images to be able to get organized, and then the program will be able to run. And then it has a pretty high accuracy because, again, it was able to work in the past. It just, after changing the data set, it had a pretty high accuracy rate. And I think I was pretty satisfied with how the program was working. Improvements would be perhaps even going even more detailed. It'd be really cool if it was able to maybe like guess, I don't know, like things like age ranges of the people who drew it, or maybe compare it to like a reference image and say, oh yes, I'm gonna rate this drawing of how close it is, and just, it would be cool because there's other directions that this can go beyond just recognizing images. It could rate them, it could tell us more information. So yeah.
Do you think your program attracts more of younger audience or older audience?
those are really broad categories, but I think in general, younger audiences, because of the fact that it sounds kind of just plain cool to be able to have a computer recognize images, but usually stuff like drawing, it's more of a creative thing that younger kids do more often. But then an adult, it's not as involved with day-to-day life is drawing. Usually kids doodle a lot more than adults, unless the adult is like they have it as a hobby or you do it professionally. So usually I feel like it's just more common for kids to doodle a lot, and then that would apply more to them. So in turn, I feel like it would definitely attract a younger audience.
Yeah, I agree.
All right. Do we have any more questions?
So for your future improvements, are you trying to create your program as an app or more as a game?
I think depending on the direction that I want to take this, honestly, it depends on what you view as a game. I would be nice if it was able to, you were able to directly upload your drawing into it and just like see what comes out. I mean, in that sense, it could be like, like you put something in and it puts something out. Like in that sense, it's kind of like a game, but I don't think, perhaps it could be implemented into a game, like to pass levels, you have to draw a certain thing. But I see it more as more like first just an application where it could say maybe you drew this and it says, oh, it's this percent. Like I'm pretty sure it's this, but it could also be this. I'm like 99% sure it's this, but not 1% sure it's this. And then maybe it'll say if you change this part, then I would definitely believe it's that. But right now, since it's trained on average human doodles, just like not to be, it's like I don't like. It's not that like they're not. These are pretty average. They're not are super artistic. So, an application, not even a fun game, but just like a fun thing that you would do once in a while. So perhaps it could implement like the back of a game, but first application on mode, just simple. Is it this? Is it that?
All right.
While I was doing this, I noticed a lot of these, almost every single one of these categories, the drawings look so much better than I thought they were. I think I really underestimated people's artists for this.
Last call for any more questions?
I'll take it. Or even if it's not about my specific program, if it's about general ones about like convolutional neural network.
All right. Well, May, do you have anything else to say?
Not about this project. I think I got to everything. So.
Great. Then, Angel, do you want to take over?
Okay. All right. Before you guys go, please follow us on Twitter at Coding Minds Academy, Facebook at Coding_Minds, and Instagram at Coding Minds Academy. That is it for tonight for Coding Minds project presentation. Thank you, May, for presenting and sharing. Tune in next week for another Coding Minds web conference, and we will see you then. We want to thank you on behalf of Coding Minds and have a great night.